Hello everyone, my name is Ryan Bernal and I am one of the authors behind the Island Stream paper, Development and Pilot User Study of a VR Anatomy Visualization Application. This paper was written by Benita Manang, Dr. San Corbani, and myself. The current landscape as well of healthcare education is that human anatomy remains a complex topic to learn for many medical students. Textbooks and real-life human cadaver models do remain effective and valuable, but they can also be quite costly, inefficient at connecting medical concepts, and inaccessible on demand. This limitation results in a lot of these students lacking the confidence they need to enter into these real-world scenarios. At the same time, the growing potential of extended reality has allowed for new immersive experiences to be created. For example, in Figure 1 as well, there is an example of a VR application called Virtual Medicine, which allows to view anatomical structures within the virtual space. In terms of using extended reality, is it meant to be a replacement for these traditional learning methods? And the answer is no. It is not meant to be a replacement, but rather a supplement to be used alongside of them. There is still a very important learning value from textbooks and cadaver labs that remain crucial for learning that cannot be replaced. In terms of the body of this research, the gist of this application is meant to be a concept platform where students, practitioners, and professors are able to learn and visualize human anatomy in both the virtual and augmented space. So a lot of these human anatomy models would be from already created 3D models or raw data from actual DICOM or Nifty slices that would be spliced and generated into a 3D mesh and placed into the game engine world where users would be able to interact with it and even view it in their world space and learn from them as well. In terms of recent trends of XR in publications is that there was a study done with XR publications spanning 11 years by Alansi as well, and that compared from 2011 to 2022 is that there has been an increased amount of publications by 17.8 times. This means that there is a increasing demand of people wanting to research into XR and utilize XR to try and answer their questions. In another VR anatomy simulation study by Homoda in 2025 with 179 undergraduate medical students, they assessed another VR anatomy simulation to assess their perceptions. And a lot of these studies and the studies showed that there was a very huge significant improvements when it comes to learning outcomes and high levels of satisfaction, meaning that there is supporting that there is an effectiveness of VR training. And another study done by Toledo in 2024 said over 90% felt that VR would enhance anatomy learning over conventional learning methods as well. And the participants also mentioned their willingness to use VR if it was available. So that there is also an increased demand in VR and that there is also sort of evidence that shows that VR can be effective at learning healthcare concepts. In terms of how this sort of application was meant for, or how it was built for testing, is that the main tools and systems that would be used is Unity Engine 6 and the MetaQuest 3 and 3S headset. Unity Engine 6 was created or selected specifically because it provides the necessary software libraries for facilitating VR and AR experiences, and the MetaQuest 3 and 3S headset does contain robust support for XR applications, and it provides a very ease of use for both developers and users alike. And when we went to build and develop this application, we also decided to do a 14-week timeline that spanned between September 2025 to December 2025. And the start with the development progress is that these screenshots often were during October 2025. And we started off by taking the template environment from Unity, and we used it as the baseline to develop the external environment and interactable objects. So there were placeholder objects that would be used for walking around the environment, and we decided to get replace those placeholder objects with having a proper immersive environment, such as the lab room that you see in the right-hand side, surrounded by a huge campus. And on the left-hand side, those were the interactable objects, which would then be replaced with actual human anatomy 3D models that would be allowed for the same interactions, such as twisting, rotations, layer toggling, and all of those features. In terms of later progress towards its current stage, is that these two screenshots were taken in November 2025 to early December 2025, and it shows the inside of that sort of lab room that we saw on the right-hand picture. So inside of this lab room as well is that you'll have a sort of console table that you'll be able to see the human anatomy model from. So the human anatomy model will be in the front and laid on this desk, and the user is able to interact with it using either the MetaQuest controllers, or they will be able to use their physical hands. As they're interacting with it, they're able to interact with the buttons on the side and actually toggle specific layers of the human anatomy. So if they wanted to focus on a specific part of the left arm, such as the triceps, or let's just say the abductors or anything like that, then they would be able to select it, and the model would update to actually showcase that, as you can see on the right hand side. The console at the same time would also display information such as text about what the tricep is or what the abductors is, and it would also come with a supplementary picture or video that would show alongside of it, just to help sort of supplement that learning. In terms of a demo video as well, this is just how the application looks like now. It has been updated since then, just because it has been quite a few months. And you can see right now is that when they go to grab it, they can grab it and interact with it and sort of look around and sort of twist it around. They'll often have now a console on their hand that they're allowed to interact with to be able to toggle the different layers. If I allow me to jump forward as well, as you can see, if I were to select a different layer, like say the extensors, now information on the head console will now be displayed, so you can read more about the extensors and also have a supplement image to go alongside of it. You're able to keep continuing to control it this way until you feel like you're done with the application, and you can also set it down. So once again, here I'm checking out the fingers and just looking at it as well and viewing it. And here is me switching to another part as well. In terms of a testing procedure, is that we conducted a pilot test with 5 students to volunteer to test the application. They were given around 10 to 15 minutes to try out the application with minimal interruption, and they were given an online survey afterwards. In this online survey, there were questions that regarded participant background, familiarity with VR, difficulty, and barriers with VR. So we're just trying to test the usability of the application to see if it's something that they would see themselves using, and see if it would even make sense in this regard. In terms of participant background, a majority of the participants held a background in computer science, which makes them more technologically inclined for using immersive systems. In terms of the age range and familiarity, many of our participants were ages 18 to 24, and many of them have expressed either using VR a few times or actually being comfortable with VR. And the final qualitative feedback behind this is that participants had the opportunity to provide any final remarks with the application. So these final remarks can include the difficulty of the application, or if they found that there was any barriers to entry into VR. So a lot of the main notable ones would often be barriers to VR would often be cost as well. And another notable difficulty of the application is that many people just didn't find anything other than just some small minor tweaks when it comes to touch point sensors or the reset buttons. The key takeaways from the study is that it does require a lot of verifying of technical libraries to make sure that the early stages of development go a lot smoother. So there has to be more efficiency during these early stages. And with more feedback, we're able to continue growing the applications to add in more features, more models, and just improve the overall user experience to make sure that it remains comfortable and effective to use. And sort of for future works, of course, this will be published for the iLEARN Conference of 2026, which is being presented right now. And the development will continue during the spring and summer of 2026, so essentially during these months, to test actual alongside nursing students rather than more computer science students to really understand the full capabilities of this application. As a final acknowledgement, we would like to thank the following: Alberta Innovates, McEwen University, participants from the Computer Science 330-499 classes, and of course, Benita Manung, Dr. Corbani, and Immersive Learning Network for this huge opportunity to be able to research.